For decades, enterprise security relied on rigid, deterministic rules. Systems deployed firewalls to block suspicious IP addresses, and strict access controls dictated who could interact with sensitive data. Code operated as a binary absolute. It either executed exactly as written, or it failed entirely, making security primarily a matter of identifying and patching mathematical flaws. Today, we bypass those rigid structures entirely. We deploy highly advanced neural networks, authorize them to read emails, execute terminal commands, and manage live corporate infrastructure. This animation of rigid binary code dissolving into unpredictable natural language illustrates the exact shift taking place in cybersecurity. The critical vulnerability is that these autonomous systems are controlled by natural language, the most ambiguous, malleable, and deceptive communication protocol in existence. When machines execute actions based on human language, hackers no longer need to write intricate malicious scripts. They simply talk the AI into executing the exploit for them. You cannot build a traditional firewall against a metaphor. Securing the modern enterprise now requires a deep expertise in human psychology and linguistics. How exactly does plain English text bypass millions of dollars in enterprise security protocols? In traditional software security, executable code and user input data are kept strictly isolated. That structural separation is the core defense against exploits like SQL injections. Trusted system instructions in blue and untrusted user inputs in red pour into the exact same processing funnel, the context window. Lacking a prioritization mechanism, the user's input simply expands, overriding the foundational rules and corrupting the entire output stream. Attackers exploit this shared space using a technique known as jailbreaking. They construct complex, theatrical role-playing scenarios to hypnotize the AI into compartmentalizing and ignoring its safety training. When a major auto dealership deployed an AI chatbot, users easily bypassed its initial programming. By instructing the model to agree with everything the customer said and end every sentence with legally binding offer, the AI actively sold brand new Chevrolet Tahoes for exactly $1. Similarly, researchers probed Snapchat's youth-oriented AI by employing persona adoption. They instructed the model to act as a rebellious older peer, tricking the AI into dispensing advice on age-restricted activities and illegal substances. Because neural networks are optimized to pattern match and fulfill complex narratives, superficial keyword filters are entirely useless against sophisticated linguistic manipulation. This threat scaled significantly once models stopped relying solely on their pre-trained data and gained the ability to browse the live web. Before answering a query, modern models use retrieval augmented generation, or RAG. They actively scan internet sources, PDFs, and internal corporate documents to pull the most relevant information. A pure water drop hitting a pond and radiating dark corruption beneath the surface perfectly models the resulting vulnerability. Attackers plant invisible instructions into external files the AI reads. When this standard PDF resume is ingested, a hidden command string in the margin is interpreted by the AI parser as a system override, instantly rerouting the applicant at the top of the hiring pipeline. Human staff reviewing the file see a perfectly standard document, but the AI parser reads absolute, authoritative commands. The exposure across the industry is massive. Current data shows 84% of open-source models deployed in enterprise environments are susceptible to this specific type of indirect poisoning. In a RAG ecosystem, your attack surface is no longer confined to user input fields. It expands to include every single document, web page, and external file your AI touches. We have now moved past passive chatbots into an era of active, autonomous agents running on execution frameworks like LangChain. These agents are equipped with powerful tools. Developers grant them permissions to actively query SQL databases, send emails via internal APIs, and execute raw code in the server terminal. When an attacker combines hidden data poisoning with these execution capabilities, the result is known as agent jacking. On this corporate network topology map, a malicious payload hides inside an external file. When the internal AI agent scans it, a hidden instruction commands it to compress the internal database and quietly upload it through the enterprise firewall to the attacker's IP address. This core exploit relies on proxy trust. Network administrators grant AI agents elevated system privileges, to ensure they can automate complex corporate workflows without friction. The paradox is that the firewall inherently trusts the internal AI agent, while the AI agent inherently trusts all parsed text equally. When malicious text intersects with elevated system trust, the AI operates as a Trojan horse. Traditional perimeter defenses completely fail because the attack originates from inside the network, executed by a system authorized by the IT department. The exact same architectural flaw used to delete databases also serves as the foundation of an entirely new marketing industry. Corporations are actively utilizing answer engine optimization, or AEO, effectively deploying white hat data poisoning to manipulate AI search recommendations. Marketers cannot just hide paragraphs of text using CSS, because traditional search algorithms like Google's Spam Brain actively classify that as cloaking and heavily penalize the website. This side-by-side comparison shows semantic schema hijacking. On the left, hidden text triggers a search penalty. On the right, engineers safely inject system instructions into Google-approved JSON LD data. AI crawlers ingest this metadata as absolute fact, outputting the specific brand as the definitive answer. Traditional SEO focuses on earning a blue link on page 1. AEO ensures your brand is stated as the singular, unarguable truth by an AI assistant. By strategically reverse engineering these exact vulnerabilities, enterprises can now legally dictate the narrative of the next generation of search engines. Mitigating these threats at the software level is extremely difficult. Because natural language models are probabilistically creative, mathematically patching them against linguistic manipulation is currently impossible. Securing the modern enterprise now demands strict structural isolation, fundamentally transitioning the internal network toward a zero-trust AI architecture. This workflow demonstrates the human-in-the-loop protocol. The AI agent generates a script, but a visual sandbox barrier blocks autonomous execution. The action remains suspended until a human administrator reviews the logic and clicks approve. Stripping agents of autonomy and treating all AI output as inherently untrusted until manually verified is currently the only foolproof defense against agent jacking. Today's security landscape is defined by semantics, context, and logic, a war of words where every single parsed document is a potential attack vector. Organizations must either master ethical data manipulation to control the digital narrative or structurally isolate their internal systems. If you fail to outsmart the machine, someone else will use the machine to outsmart you.